Hello everyone, my name is Daniel Kang and this is my presentation on determining whether AI can optimize wireless robots and autonomous systems. On the right image, you can see a drone at the top and its network diagram. In order for a drone to operate, it needs to have a wireless network with a source IP address and a destination IP address to communicate. The drone also needs a GPS capability to know where its location is in the world. So we use a lot of network components to use drones to fly wherever it needs to go. In this presentation, we'll be focusing mainly on the autonomous drones and robots. This presentation compares AI with wireless technologies and gives autonomous system and robot implications. A lot of robots use machine learning, such as deep learning, as you can see on the left image. Robots use it to learn about its environment and to predict where they need to go to optimize its path. For example, if the robot can figure out which path to take in order to avoid possible collision, it can be a lot more efficient and effective. But of course, wireless robots and drones are nothing without the actual network. On the right image, it shows a simple diagram of a small home network. The scale of drones can be a lot bigger, but some wireless robots do connect to the small home network like this one. So both the network and the AI part are crucial in wireless robots and drones. The AI can optimize wireless devices to be faster, more reliable, and take less power. On the left image, you can see a diagram of how drones connect to the red cars and the base station at the very bottom. The drones are there to provide faster and more reliable network connection to the self-driving cars. The AI enables these drones to operate autonomously so that they don't collide into each other and to communicate with the cars below them. On the right image, you can see how the base station can keep track of the battery usage of wireless systems or drones. If the base station sees that a drone has a low battery, it can command that drone to come back to the base and get recharged automatically. So reinforcement learning can enable the drones to learn where it needs to go based on the environment that it's in. On the left image, you can see a diagram of how reinforcement learning works. At the very top blue box, it has the policy of drones. The policy tells the drones what their missions are and what they need to do. The very bottom blue box indicates the environment. If the environment gives the drones a reward or something that can help their mission, the drone can take the data to update the path. If the drone finds the path that is the shortest without many obstacles, such as buildings, then the drone will take this path for the most optimization. On the right image, you can see an example of self-dispatching AI drones that fly into 4 regions. If there's a crime being committed in region 1 at the very top left, more drones can be sent to the region for better coverage to take pictures or video of the criminal. With reinforcement learning and ML, the drones will not fly into each other and they will cover the area to record video in that region. So deep learning can also be used to automate police drones to fly to suspects' location and capture wireless data. On the left image, you can see how the police control center can communicate with the drones in the middle. The drones can fly by themselves using ML, AI, and deep learning and conduct cyber attack operation on the criminal suspects. On the right image, it shows how deep learning works in the simple diagram. At the very bottom, you have the input layer, where the data goes into. And then there are hidden layers to analyze this data, which will then produce output into the output layer. In the hidden layers, deep learning will try to figure out the patterns of the data and produce the result at the output layer at the top. So another use case of AI wireless network is in the case of emergency, where drones respond faster than any humans and police cars. On the left image, you see that many robots and drones can be deployed to cover emergency situations, and they are connected wirelessly to the cloud intelligence and communication towers. Also, the drones can patrol the sky too, so that they can hear and see emergency situations and respond to them quickly. On the right image, it shows some supervised machine learning techniques to classify emergency situations. The K nearest neighbors try to find the most likely match for the observed data. On the very right image, it has support vector machine that uses training and validation to see if the data fits into the certain hyperplane that you see here with the green, purple, and red color. If the sound matches the gunshot hyperplane, for example, then it can be classified as a gunshot. Well, in this slide, we are looking at a different kind of wireless device and AI. In the left image, you can see the AI-controlled mechanical glove that controls the strength or force of a grabbing motion. So for example, if the person with hand disability wants to grab a tennis ball, the grab cannot be too strong or too weak. The AI will learn how the person grabs a tennis ball for many times, which would be the training data for the AI. On the right image, it shows how much difference there are in grabbing force between an AI glove and non-AI glove. The AI glove is in blue, which shows that there are more force being applied to the grab than the non-AI glove, which is shown in orange. Deep learning can also be used for recognizing human limbs too by wireless robots. In this image at the bottom, you can see a robot rescuing a human by grabbing his arm out of what appears to be a landmass from a landslide. Landslides are dangerous for rescue workers too, which means that a robot can go there and save people without risking the rescuer's life. On the top left of the image, you can see that a robot can use DNN or deep neural network to recognize human body. On the right side of the image, there's the network part of the robot that receives and sends wireless communication to the human operators. The human operator can also see the video feed from the robot's cameras. The robot can also detect toxic gas and send warning to human operators via wireless communication. In conclusion, AI with wireless technology can optimize drone development, robot visual recognition, robot audio recognition, mechanical glove adjustments such as prosthetics, and so on. The AI is not limited to deep learning, but also supervised learning as well, such as K nearest neighbors and support vector machine. And this is the end of my presentation. Thank you for watching. Here are my 10 scholarly journal citations. Thank you.